derivative of this function here. So you're in some sort of calculus class, I don't know, business calculus, regular
Right.
calculus. Derivative of this, derivative of a constant is 0. Derivative of this right here, it's a constant times a x squared or t squared. So your derivative, your dp dt is 12,000 t, because you take that exponent multiplied by the 6,000 and multiply by t.
Okay.
Is that okay?
Yeah.
So that's part A. I'll try to box in those answers. The part B, the population. Well, the population comes from this formula right here. So for part B, you're finding T of 20. You're putting 20 in for T. An extra 0 there. Plus 6,000, 20 squared like that. So if you got a calculator handy, I'm going to do the same thing. Always good to double up in the calculations, especially when it's graded for that. So we got a 200, 1, 2, 3 plus 6, 1, 2, 3. So 2,600,000. No commas in the answer. Now the growth rate, that's the derivative. That's p prime of 20. So you're putting that into the derivative function. 12,000 times 20 is 240. 1, 2, 3 zeros there as well. Okay. What is the meaning of the answer? Part C. It tells you the rate. So the derivative, if you haven't figured that out yet, the derivative means rate.
Right.
That should be very clear. It tells you the rate at a particular time, which happens to be 20.
Okay.
All right. So, what's the amount of work to show? I mean, I don't know. I mean, probably what I put down, and
Right.
then maybe some words something that says derivative is rate.
I think like even like you probably even want like to see me multiplying 2 into 6,000. It's like,
Possibly.
yeah, for
Yeah,
like
I
the
don't know.
derivative. It's like he's
I don't know. I mean, that you know what they want at this point, I would guess, in the class,
I
but
hope so, but like it kind of confusing because like I showed like some work on my last exam, like he even like put where's the work, even though like I showed my steps. I'm like, okay. Uh
this is the classic nature of college. You
yeah,
want the grade, and you're playing the game with them of doing it the way they want. And the
right,
way they want is for you to just do it their way. You do it their way, you get the grade, and then you get to be able to move on to the next class. So
right.
sorry, that's just the way it goes. All right. Yeah, so whenever you want to snip in that next one to the chat, and let me know when you snip that in, because sometimes the notifications don't appear
Okay.
right away, and don't want to miss out on that there.
All right. Pasting it, and then it should be in the chat.
All right. So that this was a little more efficient. There we go. Okay, now just a quick thing on problems where it goes way across the screen. Sometimes it's good if you can make your window like half screen so that the text wraps. Although it doesn't
Okay.
matter too much in this problem, but just that would help here a little bit. So what is the maximum profit? Well, the profit, we actually talked about this in a previous course. It's revenue minus cost. So it's that 5x minus 0.05x squared plus 0.6x plus 5. You want to show that parentheses or that negative being distributed to everything. And so you get minus 0.05x squared plus 4.4x minus 5. That's your profit function. Okay, it's not the answer, but that is the profit function. So from here, there's a couple ways to do it. If you didn't have to show work, we would just graph this and then find the peak right there. But
Right.
you're in a calculus class, you have to take a derivative, or you're in a show work class, you have to take a derivative. So your derivative here, You get power rule. So 2 times 0.05 minus 0.05 is minus 0.1 x plus 4.4 equals 0. So you set your derivative equal to 0, and then you'd solve for x. X ends up being minus 4.4 divided by minus 0.1, which is 44 units. Now, I'm assuming you had some homework in this course, so sometimes the homework problems kind of lend you to like knowing like, okay, yeah, that's reasonable answer. You can't have half a unit, it has to be a full unit
Right.
like that. Now, full disclosure, you're really supposed to actually show that it's a maximum. So you're supposed to actually say, okay, 0, 2, and actually this right side, I don't know the value of, but this 44 is actually just what's called a critical point. And you're supposed to test points between 0 and 44 to this right edge. This right edge here comes from wherever the graph hits 0, which, again, there's a lot of work here to do if you actually want to do this right. But you would show that the graph is increasing and then decreasing. So therefore, this is a max. But I mean, I don't know if you need to do all that. That's
Hopefully
another
not.
string.
Maybe I can like show a sketch of the graph.
There you
And
go.
say,
Maybe
yeah.
that's the compromise. So now the profit itself, you have to take this 44 and put it back into this line here. So I'm going to grab that line and we're going to find the profit of 44. I use PR for profit because sometimes P stands for price in other parts of the course. Like that, and get that number. So let me do that here for you. We got x equals 44. Negative 0.05 x squared plus 4.4 x minus 5. All right, so I got 91.8. I don't like that. Does it say that it's in like thousands or something?
Um,
It's in dollars. Okay. So I guess it's 91.8. Maybe double check that.
oh yeah, it doesn't like give me the answer right away. I have to like submit it and then check.
What I mean is like double check my calculations. You're like go through
Oh,
and yourself and just verify that you actually, I mean, I don't know, just having done a million of these, not a million, we've done hundreds of these problems for students. I mean, just that doesn't quite look right, but let me look one more time. 0.05 x squared. Oh, 0.6x. That's a 5x, right? Yeah, 5x, 4.4. I mean, it looks right to me. Okay.
yeah.
All right.
All right.
So like I said, we're definitely not going to get through all this in the time today. So
Just
you may
try
want to pick
it.
and choose questions you want us to actually go.
I think they're all fairly distributed like pretty well. So we'll cover a lot in the time, I guess. So it'll be
Okay,
fun.
sounds good.
I'll paste the next one. So it should be in the chat now.
All right,
This one has like some drop down options, but
let's see if we need them here. All right, so a vending machine purchase $6,400, salvage value V depreciates by called the double declining balance by 30% each year is given by this function here. Okay, so part A is not a calculus question. It just means to put 5 in for this function here.
right.
So it's 6,400.7 to the power of 5. So grab your calculator and give that a try here. All right, and it says round to the nearest cent. So I got 1075.65 like that. You can double check that.
I got that.
All right, so the expression V of 5 means that after 5 years, the salvage value, what's in the drop down
It says is and is changing by,
is and whatever this, it's probably this number right now.
which is like V
V of 5.
$5 or dollars per year, or
It's
the
just dollars,
derivative.
just
Yeah.
dollars. Yeah. So the idea is that like you sometimes care about how much something actually costs, or is worth, and then you also sometimes care about what the actual rate of change is.
Right.
Although this is a terrible example, nobody buys office machines like this anymore, but that's what we have. So for part B, you have to be able to take a derivative. You have to take a derivative of this. So this is a different derivative rule. You're kind of at this part in the course where it looks like you're supposed to have known. You're supposed to know all these. When I say that, I just mean like and I'm happy to cover them, but you've seen them in
Yeah.
detail. So what I'm sending over to you by the chat is a reference sheet that I send to students for this course, so you can get a feel for. But let me just give you the derivative, and you can ask questions if you have any. So the derivative is 6400.7 t times the natural log of 0.7. And if you're not sure where I got that, it's the exponential logarithmic function derivative, which I'll snip in as well. So one other thing in this course is like just knowing how to take a derivative of something.
Yeah.
All right, and then we actually have to evaluate at 5, so v prime of 5. So you're actually, what kind of a shortcut here is you're actually reusing part from part A, but don't use the rounded answer, natural log of 0.7 like that. And rounding to the nearest just cent. So it is negative 383.66 is what I've got. You might wonder, well, why is it negative? It's because it's going down. The value of the office machine is decreasing. It's going down, 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 down. And
Yeah. Which is like the change.
yeah,
Okay.
changes can be negative,
Right.
breakups or, whatever. So after 5 years, the salvage value is changing. I don't know what the is.
Is
Was
or
it
is changing by.
is changing by? Yeah, there you go. Changing by, and then it's V prime of $5 per year.
Right.
All right. Any questions on that before we do part C?
No.
All
Seems
right, so
fairly.
the original purchase price is 6,400. We want to know when it's half, that's 3,200. When does 3,200 equal 6,400? 0.7 to the T. So you're just solving for T. And now this is not a calculus question, but it's an important question. So you divide by 6,400,
Okay. Yeah.
you get a half. The only way to get T out of the exponent is to use natural log. Okay, so it's T natural log of 0.7, natural log of 0.5. You divide by natural log of 0.7, like that. So you end up getting T equals natural log 0.5 divided by natural log of 0.7, like that.
Right.
And we'll get a number for that. It should be like there's reasonableness here. Like, I mean, it's not going to take like 400 years, but it's going to take a few years. So what does it say to round to? The nearest 10th?
2 decimal places. Yeah.
So I got 1.94, and probably good to check me.
Yeah. 1.94.
So I mean, it's pretty quick. Drop 70% twice, and you're down to half your value in 2 years. Bars drop, 80% in like a year to 2 years. A lot of savings are made by buying a 2-year-old car or older.
Right.
Let someone else take the hit.
Uh,
And this is all good for work. I mean, if you're getting all this down, as you know, I sent it to the end, but that's all pretty good for, I would think this is sufficient.
Yeah. I'm actually gonna skip some questions here.
Sure.
Uh, all right, sending it to the chat.
All right. Yeah. So these types of questions, sometimes good to send them, kind of like for, like through A and then maybe send, B, C in a different one, but
Okay.
we'll
Yeah.
we'll make this work. We'll make this work here. Okay. Um, how many determines monthly sales, S of T in thousands of dollars? So why don't you try finding the derivative here? Giving me the derivative of this function. And while you're going to do that, while you're doing that, I'm going to step away and grab some coffee. But why don't you, so you can take the derivative, and then if you can take the derivative, you're just evaluating it at one here. But I'll be right back.
All right.
All right, how are you doing on the derivative?
I got it. I got 6t squared minus 80t plus 210.
Good. So the next parts of this are to evaluate at one, and I'm guessing the dropdown are the units. So it would be like thousands
Yeah,
of dollars per year,
per month, and then
per month.
squared.
Yeah, per
No,
month.
yeah.
And then for the second derivative, here, 12b minus 80, it would be thousands, like you said, of dollars per month squared for the units. So happy to evaluate these if you want. You can do them on your own. We can talk about part C.
Let's just talk about part two.
Okay, after 1 month of marketing, sales are, and so that's based on, it's probably asking about the derivative. It's like, it's either increasing or decreasing. Is that what the dropdown says?
Yes.
So it's based on the sign. So if S of one, which, yeah, S of one is positive, so it's increasing. And I don't know what could be here.
Growth is slowing down,
So
decline is
that,
slowing down. Yeah.
so that depends on the sign of the second derivative. So if there's kind of a rule here for based on um, first derivative and second derivative. So if they're in the same direction, these are considered the same direction. It's like accelerating, meaning it's like getting worse or getting better.
Right.
If they're opposite in sign, they sort of cancel each other out. It's like decelerating. So in month one, so S double prime of one is negative. So it's going to be like, I don't remember what the options were here, but it's going to be like the one where they're counteracting each other.
Okay. So
Is that,
decline is slowing down or growth is
yes.
slowing down.
So decelerating is slowing down,
Yeah.
slowing down, speeding up. So like think about driving. You're going down the road and you hit the gas. Okay, that you're
Mhm.
accelerating.
Yeah.
Um, you're slowing down and then you hit the brakes. So like you really slow down. You know, this is you're slowing down, but then you hit the gas, or you're hitting the gas and you hit the brakes. So they kind of counteract each other.
Yeah,
Is that enough, or do you, I mean, I'm happy to give you all this.
that's enough. Yeah,
You can see that it's very repetitive.
right. I like the little explanation for the C because I got a little confused back then.
And probably these are in Quizlet, Course Hero, you know, usual places if you're really stuck on them. As well.
Right. All right, I'll post the next one.
Okay. Jump to first unread message. Okay. That. Alrighty.
Should be in chat.
Go.
Equilibrium. Oh, that's just. Okay.
Find the equilibrium point. That's setting d of x equal to s of x. Now the next part, B and C do require us to actually find this. So we're going to set these equal like that. And then we're going to solve for x. So if you got to do this by hand, I guess I would clear the fractions first. So minus 5x plus 72 equals 3x plus 24. And then move the 24 over, add the 5x. So you end up getting 48 equals 8x, x equals 8. Like that. And then to find the y value, you have to put 8 into one of these equations. It doesn't matter which one. I'm going to choose the second one because it's easier. So s of 8. The reason it's easier is 1/2 of 8 is either than 5/6 of 8. But why don't those give us the same value? There's something off here. Because they need to give you the same value. 5/6 of 8 plus 12 is not the same as this. So let me do something else here to check this, is to graph it. Make sure that we actually get the values I'm expecting. Minus 5/6 x plus 12. And then the other one is 1/2 x plus 4. You're literally just finding the intersection between the two of them. Okay, so I just divided wrong. I don't know why, but that's 6. So it doesn't. So now it does work. Add so 6 plus 4 is 7. So your ordered pair here is 6 on the 7 for this one right there.
All right.
All right, now I'm going to grab a picture of this. Actually, grab one more intersection point. Boom, boom, boom. All right, have you taken economics class yet?
No.
Okay,
I think
you'll see this
this.
again in economics with
Yeah.
like an econ 200, where so there's if you draw this horizontal line, this triangle up here is the consumer surplus. I really double check that. That down here is the producer surplus. Now there's a calculus way to do it, but there's also the fact these are triangles and you can calculate the areas of triangles. Do you remember what your instructor wanted you to do here?
It wasn't triangles. I don't recall that way. It was like
Okay,
a
so here's the calculus. What you're going to take to find the consumer surplus, it's the integral
integral. Yeah.
from 0 to 6. Now, why is it 0 to 6? Because it's from 0. If you go down here, 0 to 6. This red line, okay, top, it's called top minus bottom. The top line is the one that's going down. So minus 5/6 x plus 12 minus this horizontal line here, which is 7 dx. So there's some formulas. Let me see if I have like that. I used to have like a business calculus reference sheet. Do you have a reference sheet in this course or not?
No, we didn't get one.
Or where I mean, where are you taking this class? If you don't mind me
This
asking.
isn't on there. Like what school this is for?
Is this University of Arizona, Pima? What do
Pima,
we got?
Pima.
Okay. I'm only asking because, yeah, I'm just trying to figure out here. So here are the two formulas for producer and consumer surplus. So you can see in the producer surplus, this top one here, you subtract out P bar. P bar is the average right there. And the demand function. It's always the one sloping down though. It's the other way to look at it. But you have to be able to find the antiderivative of this. So if you're in this part of the course, this is where it can get really confusing. Like, how do you go, we were just doing derivatives, now you gotta find antiderivatives.
Right.
You remember any of the antiderivative rules?
It was, let me think. Yeah, I can remember the rules. It was like, basically just multiplying by X and then dividing the bottom with that number. It's just, that's how I make sense of
Uh,
it.
So in words, you add one to the exponent
Right,
and divide by the new exponent.
right.
Okay, and then over here, you're like, well, this one doesn't have one. Well, it kind of does. It's really X to the 0. So it
Yeah,
ends up being X to the
one.
1. So this becomes minus 5x squared over 12 plus 5x evaluated from 0 to 6. And it's top minus bottom. So you're going to put 6 in for x. And then when you put 0 in, nothing happens because it goes away. But it's minus 5 over 12 times 6 squared plus 5 times 6 minus. And I guess because you have to show work, we're going to show this even though it's 0
Yeah, yeah,
like that. So it's just this part that you care about. 36 divided by 12 is 3 minus 15 plus 30. So this ends up equaling 15 for the consumer surplus. And your calculator will do up to a quadratic integral exactly every time. I don't know if you've used a FN int in your calculator. You're trying to like work around, get the right answer, but that will always work
mm,
for polynomial degree 2, like this, like a quadratic or a line. So that's that's consumer surplus. Producer surplus is the one on the bottom here. Let me know when I can move to that.
you can move on, yeah.
Right, so it's the integral again from 0 to 6. Notice the bounds are the same in both of these. They're always the same. This time it's that 7 minus, instead of the other way, your other function, which was 1/2 x plus 4. And be sure that you subtract the whole thing. So it's 7 minus 1/2 x minus 4, 3 minus 1/2 x, and you have to take the antiderivative of that. Putting your dx's here to be really classy. So this is 3x minus x squared over 4, evaluated from 0 to 6. And again, the bottom bound is 0, so nothing to be there, but you've got to show your work. So you put this
Right.
in. Is the whole class online, or you going in person for instruction, or?
No, everything's online.
Well, that's a lot to ask here. 36 over 4 is 9. 3 minus 6 is 18. 18 minus 9 is 9, is the producer surplus.
Right. This class is, oof, I wish it was, I wish I had a different teacher for this one.
Yeah, you're not alone. The calculus gets real tough. You gotta have the right instructor to help
Right.
you
It's just, this
navigate through it.
class is really disorganized and I'm feeling it.
Well, you gotta be, you're pretty much at the end as far as I can tell.
Yeah, it's just as long as I, do decent on this final, that's all that matters. Like, if I just do enough just to pass, like I'm good. That's all I needed.
Right. Well, whenever you're ready, if you want to send over something else for just to look
Yeah,
at, we can.
I'll paste this
Um,
second, the next one, and should be in now. So it's another, I think, antiderivative question. Yeah.
Find the demand function, given that B equals 12,000, X equals $4 per unit. Yeah. So you're finding the antiderivative of this, and I mean, this is pretty challenging problem here. You have to be able to know quite a few things about calculus to be able to do this. This is a U substitution problem,
All right.
and I don't know how they're telling you this, but you don't have a rule for this. Like if you go back to that reference sheet I sent you, you don't see anything like this. Like you kind
Yeah.
of see the bottom in a like an arc sign, I think, but this is not an arc sign. This U substitution is a big deal in calculus, but I mean,
It was the
you're
most
sorry, go ahead.
it was the most confusing for me. Like, yeah. I
Yeah,
yeah.
so you're trying to make this into something you can integrate. And du here is minus 2x dx. And then you have to solve for dx. So your dx is du over minus 2x, if you're dividing both sides by that. Now you substitute in for your u, that's down here, and for dx, which means you leave this at the moment. You're like, wow. And what you're hoping for a cancellation. Like you're really hoping, you're saying, I hope some things cancel. And look at that. The x's do cancel. So yeah, the x's cancel. Minus 2000 over minus 2 is 1000.
Hmm.
So and often it's good to bring the constants out. So this thing that looked really complicated becomes 1000 integral 1 over square root of u du. And this is much more manageable.
Yeah.
Now this whole idea of u substitution is like solving you're changing the space of the problem. You're like, I'm not gonna do it in terms of x, and there's this linear superposition thing that's going on here, which, you know,
And
not, we're kind of a little bit of magic here. I mean, a little bit like just waving your hand saying, ah, yeah, it's
yeah,
gonna work out, but it
just
does.
and then what you did was just find the derivative of
Yes,
the 25. Okay. And then
yes.
put the 2x under. All right. Okay, yeah.
All
That
right,
makes a lot more sense.
so now it's kind of something you can do. Now I would still do a rewrite step. And so I show this a lot to students who are taking calculus. Is there's a lot of rewrites, which is basically using the stuff you learn in college algebra, pre-calculus. In this case, you're just using your exponent rules here, because this is now power rule integral. So that on your reference sheet there, integral x to the n dx is always x to the n plus 1 over the new exponent n plus 1 plus c. So you're going to add 1 to this exponent. Okay, and that's where a lot of students stumbles. They're just not comfortable with that. You divide by the new exponent, and then you have this constant here, plus c.
Right.
Is that okay so far?
Yeah.
So this becomes 2000. Now instead of you go back to what you were using, which was 25 minus x squared for u plus c. And this is your demand function. Remember, 1/2 really means square root, so it's good to rewrite it, especially when you're going to evaluate it here.
Hmm.
Is that okay so far?
Yeah.
Okay. If it's not, just say so. Hey, I don't understand. But you use power rule to integrate, then you back substitute, and now to find c, we're going to use this initial condition. This right here is called an initial value problem, IVP, or initial condition. Basically, it allows you to find c. And this we could talk at length why there's a c, but there's a c.
Yeah, there's just a C.
There's a c. So demand is 12,000. Sometimes you got to look to make sure that the demand is actually in like that. It's not in thousands or something else. So this one is literally 12,000 equals 2,000 square root 25 minus 4 squared, because x is 4. So 25, 4 squared is 16, 25 minus 16 is 9, square root of 9 is 3. This becomes 6,000 plus c. So c equals 6,000. And that goes back in this line here. So your final answer here is to substitute in for c. And this is, I believe, what it wants in that box there. Yeah.
Right. Hmm. So,
Why did I get that? Any questions on that?
No. Alright, I'll move on. I think, let me look. I think this might be another one. Alright, I'll send in chat.
Something new there. Is your is the real thing very similar to this, or is it easier?
No, it's different, which is weird. I
Yeah.
like, yeah.
All
It
right.
gets the general gist of the questions down, but it's kind of structured completely different for the test itself.
Okay. Is it through the Pearson or is it like Canvas?
It's like through a D2L thing.
Okay,
Not sure. It's like they write their own questions, but like it's like almost like a free write like
I
thing.
see. I
So
see.
yeah.
Okay. All right. Find the average weekly sales. So this is a known integral. The integral for average is 1 over b minus a to b, f of x. Yeah. All right. So in this case, your f of x is this s of t. First 5 weeks means from 0 to 5. So it's 1 over, think of that as a and b. 1/5 minus 0, integral 0 to 5, 4e to the t dt, like that.
Right. Okay.
So this is a known formula. All right, so the 4 can come out, so it becomes 4/5 integral 0 to 5 e to the t dt. And this is supposed to be one of those that you say, oh, great, I know how to find the antiderivative of e. The antiderivative of e is itself. Okay, so this becomes e to the t. There is no plus c for what's called a definite integral. Definite integrals have these bounds on them. And really mention that, but that's there are 2 types of integrals: definite when the bounds, indefinite where they don't. So that's 4/5 e to the 5th. Well, you can put the constant with if you want, minus 4/5 e to the 0. And I think it says here to round to the nearest cent.
Right.
Now this is in hundreds of dollars, so you actually have to multiply your answer here by 100, which these are kind of these tough questions where you have to, because if you do this, you're like, oh, it's not that bad, it's not that much, but when you multiply by 100, you get the real answer here. So I would just throw it all in the calculator if you're not. That would be a good thing to start
Yeah.
doing, so that you're. All right, so when I do this, I get 11,793.005, like that.
Oh, so yeah. Oh, wait a minute. I think I got a slightly different answer. Wait, hmm, wow. It's weird. I got 11,773 instead of that.
Yeah, I don't know. I put all this in the calculator.
Yeah.
Uh,
Hold on. Let me clear my data. Calculator sometimes bugs out.
And I'm not doing any intermediate rounding, doing the whole thing here.
Okay, yeah, I got it. Something happened. That was weird.
Probably got time for one more, maybe. Depends how long it is, but you can drop something in the chat there whenever you're ready.
Yeah, this I think will be a good one for me. I'll post in chat.
So rate of change. Okay, so total private. All right. So first one is asking for R prime of X, which is the derivative of revenue of
Yeah.
X, which is just 2.
Yeah.
That's nice. Okay. The second one is C prime of X, which is the derivative of cost, which is 0.02 X plus 0.2. So that's your second box there. And then profit, as we know, profit is revenue minus cost. So the derivative of profit is the revenue prime minus C prime, which is 2 minus parentheses 0.02x plus 0.2, like that. And you do want to simplify here, and that's right, you got to show all your work. So it looks like it would be like 1.8 minus 0.02x for the rate of change of total profit. However, sorry, these are not right. There's more here to this. I just realized. So they're giving you the X values. I didn't realize they were giving you X values. These are just the functions. So full disclosure, R prime is not quite right. It's 2 dx dt,
Mm,
and C prime is also got a dx dt, like that. And same thing with this last one here. It's got a dx dt. So for the first one, for revenue, it's really 2 times 8, which is 16. So
right.
these are related rate problems. Cost function C prime here, we've got to put in X 25 for dx dt. So I'll do that in the calculator. So we got a 8 times 0.02 x plus 0.2. So I got a 5.6 for that. Probably good to double check these. And then actually the rate of change, you don't have to use this formula. You could just take the difference of these, or you can use the formula and see that it gives you the same result.
Mm-hmm.
Which, you shouldn't be surprised. 16 minus 5.6 is 10.4, like that. So the easy thing to do here is when you see the dxdt here is to just append it to the end, and with the full end, like it's in parentheses, um, like that.
Right. All right, and I think that's it for now.
Well, we got time for here, so we'll go ahead and
Yeah.
stop here. So, I've got